Hello everyone, I am Mr. Ashish Chaudhary, Assistant Professor of Mechanical Engineering Department, VPM's Maurice Parashuram College of Engineering, Village. Today, we are going to start a lecture series on a power engineering subject. In that, we are going to start a first lecture on a boilers. It is also called the steam generators. Okay. So, first we define the boiler. So boiler is a device used to generate steam at a desired pressure and a temperature by transferring heat energy produced by burning fuel to water to change into the steam. That means it is a device we will supply the fuel. After burning the fuel, we will convert the liquid water into the steam at a certain temperature and the pressure. It is combination of apparatus used for producing, furnishing or recovering heat together with the apparatus for transferring the heat so made available to fluid being heated and vaporized. So that means in that we will convert a liquid water into the gaseous form of water, that is steam. Now function of water. The fluid is contained in the boiler, the drum called the shell, and the thermal energy released during the combustion of fuel is transferred to the water, and this converts the water into steam at the desired temperature and pressure. So that means so boiler is made up of one of the metal shell. In that we will store the water into the shell in the uh, chamber, or we can say into the tubes, and thermal energy will be released, or it will be transferred to that water by using burning of or combustion of the fuel. And after supplying the thermal energy, that water will be converted into the steam at a required pressure and temperature. Now application of boilers. So this application of boilers, first one is the power generation. Mechanical or electric power may be generated by expanding the steam into the steam engine or the steam turbine. That means in the boiler we will generate the steam that will be supplied to the turbine, and when turbine will be rotated, the mechanical or the electric energy will be generated. So that means first application of boiler is power generation. Second application is heating. The steam can be used for heating the residential and industrial buildings in cold weather and for producing hot waters for the hot water supply. Okay, so second application is heating. So we will supply the steam to heating the residential area. Then third application is industrial processes. The steam can also be used for industrial processes such as for sizing and bleaching, etc. in textile industries, and other applications like sugar mills, cement, agriculture, and chemical industries. That means there are the number of applications of boiler into the industries also. Now we'll see factors considered for selection of good boiler. So which are the factors? So first one is the working pressure and quality of steam required. Okay. Then steam generation rate, how much amount of steam will be generated. This is one of the major factor. Then floor area available. So how much area is available, depend upon that we will use the particular type of boiler. Accessibility of for repair and inspection. So this is a major factor. So that means mainly how much or how efficiently we will repair and inspect the boiler. Then next is comparative initial cost. So we will consider a initial cost must be as low as possible. Erection facilities. Then portable load factor. Then the fuel and water available. So how much fuel is available at particular site, how much water is available at particular site. Depend upon that also the boiler selection will be considered. Operating and maintenance cost. So this is a major factor. So how much operating cost and maintenance cost will be required for a particular boiler. Okay. Now, so requirements of an efficient boiler. Next point is that the requirements of efficient boiler. So which is first one, the boiler should generate maximum amount of steam at a required pressure and temperature and quality with minimum fuel consumption and expenses. So that means a particular boiler will be required as a maximum amount of steam will be generated at a particular pressure and temperature, and quality of that steam will be a good quality depending upon the fuel consumption and expenses. Okay. Then steam production rate should be as per requirements. So steam production required as per the conditions. It should be absolutely reliable. So obviously we will require a reliable the boiler. Then it should be light in weight. Okay, so for transport condition, it will, this is a main factor. It should not occupy large space. Okay, so that means we will require the less space will be used for that boilers. It should be capable of quick starting. Okay, some of the boilers, the starting process of the boiler is so much hectic, so that means it should be capable of quick starting. It should conform to safety regulations. So safety regulation and safety devices will be used for that boilers. The boiler component should be transportable without difficulty. Okay, so boilers components we can transport very easily. The installation of the boiler should be simple. It should have low initial cost, installation cost, and maintenance cost. So obviously it will be, if you compare or the if you fix the cost of the boiler will be low as much as possible. It should be able to cope with fluctuating demand of the steam supply. So sometimes what will happen, the steam generation will be fixed one, but the demand will be fluctuating. So according to the demand, the steam generation is going to fluctuate. So this is the first one. The all parts and components should be easily accessible for the inspection, repair and replacement. So that means that parts will be easily, you will get the parts will be easily available, and we can easy inspect and repair that parts. The tubes of the boiler should not accumulate soot or water deposits and should be sufficiently strong to allow for wear and corrosion. So that means the steam material, tube materials will be as a good one. So that means there is no accumulation of some of the depositions like minerals. And what will happen if minerals will be accumulated on the tube, then heat transfer rate goes on decreasing, and that means there is a thermal conductivity goes on decreasing of that pipe material. So to avoid that, the pipe tube material will be as good as possible. The water and gas circuits should be such as to allow minimum fluid velocity for low frictional losses. That means if we increase the velocity of the fluid into the tube, so obviously friction is going to increase, and if friction will be increases, wear and tear going to increase. Okay, so to avoid that, we'll require water and gas will be flow into the pipes at a low velocity. Okay, so now next one. Now the main point is during the discussion of boiler is classification of boiler. So classification of boilers depend upon several components. So first one is the relative position of the hot gases and water. Okay, so how the gases passes into the boiler, or how the water will be passes into the boiler, depend upon that. There will be two types of boiler. The first one is a fire tube boiler. That means the exhaust gases after burning of the fuel, that will be flow through the tubes. Such type of boilers are called as fire tube boilers. So some of the examples are Cochrane boiler, Lancashire boiler, Cornish boiler, and locomotive boiler. Now next one, the water tube boiler. If water will be flow into the boiler through the tubes or the pipes, then such type of boilers is called as water tube boilers. And the examples are Babcock and Wilcox boiler and Stirling boiler. Now next one, second method is method of firing. Second classification is depend upon method of firing. So first is internally fire boiler. That means the fire will be taking place inside of the boiler. Such type of boilers are examples Lancashire and locomotive. And externally fire boilers. So these are, that means outside of the boiler there will be fire will be takes place. And such type of boilers are examples Babcock and Wilcox boiler. Third classification is pressure of steam. Okay, so this depend upon that one. There are the two types. First one is higher pressure, and second is lower pressure boilers. So higher pressure boilers, if you consider pressure in the boilers or the steam pressure will be higher than 80 bars, such type of boilers are considered as a pressure boilers. So examples are Cochrane, Lancashire, Cornish, and locomotive boiler. And low pressure boilers, if pressure is less than or equal to 80 bar, we will consider that boilers are low pressure boilers. So that are the Babcock and Wilcox boiler, Lamont boiler, etc. The next classification is method of circulation of water. The first one, natural circulation of boilers. That means due to the density difference, the water will be circulated into the tubes or the shell, into the shell of the boiler. Then such type of boilers are considered as a natural circulation boiler. So that means examples are Lancashire Locomotive, Babcock, and Wilcox boiler. And forced circulation boilers, that means water will be circulated through the tubes by using a force one. That means by using pumps, uh, etc. So that means two large fire tubes, Lancashire boilers, single large required. So such type of boilers are called as mobile boilers. Plus boilers. Next classification is nature of draft. It is natural draft. Coal, liquid fuels, that means oils, and gaseous fuels if you consider. The steam. Then next is the hot waste gas. That means converting from liquid to the gas state. Inside the tubes and water outside the tubes. So hot work under a high pressure, that means up to the 100. But opposite to that, water tube boilers, it is for transportation. Shell and diameter